Hello there, dear students, and we are back again to study chapter 5, section 3, topic which is about spherical mirror. In the previous section that we have studied reflecting light on flat mirror, but now we are going to study how the light is going to be reflected if the type of the surface spherical mirror. So then we have two types of spherical mirror actually. One of them which is called concave spherical mirror and convex spherical mirror. So today only we're going to explain concave spherical mirror. First of all, let me tell you some note about what is spherical mirror or the shape of spherical mirror. Types of spherical mirror. Spherical mirror. The first type, concave spherical mirror, and this is the shape of concave spherical mirror. This is the shape of concave spherical mirror. This is concave spherical mirror. Concave spherical mirror. Okay. And the second type, which is called convex spherical mirror. This is the shape or convex spherical mirror, like both of them, they have the opposite direction. This side, this picture is to the left, and that one to the right. So this is convex, and that one concave. What is the definition of concave spherical mirror? Concave spherical mirror, the question said, the definition said, a mirror, so this is type of mirror. So we have now a lot of type of mirror. Flat mirror that we have studied, the surface is flat, straight. But now we have concave, like a curve, like that, the shape. Look, this is like a curve, the sphere, the mirror in here that like a curve. That's why we said concave spherical mirror. A mirror whose reflecting surface is a segment of the inside of the sphere. You know what's the meaning of definition? It means we know that circle. This is the shape of the circle. This is the shape of the circle, right? If only to take this segment يعني parts. If only to take this segment, this part. If only to draw this part, it will be like that. Look, it will be like that. If we notice that this is the circle, I only took this segment, this part of the sphere. This is the shape will be after I took this shape. This is the shape. This is the part of this sphere, this circle that I have, that I took this part. Take this part, only take this. Take this part only. This is the picture will be like that. So this is called concave. And we can, maybe you have question, Mr. Where did these pictures came? The pictures came from this circle. We have we took the part inside this circle. Maybe you have a question, Mr. Where did these pictures came? Concave spherical mirror. Actually, this is the circle, and we took this part and drew this part in here. This has become concave. As a definition, same thing. Look, a mirror whose reflecting surface. Why we are using this mirror? For reflecting light, for reflecting surface, of course, is a segment or part of inside of the sphere. The whole sphere. This is the one sphere, the whole sphere. I only take this part of the sphere, so this has become concave. This concave is one of the part of this sphere. It's one of the part of this circle. So students, we studied the property of flat mirror. If you remember, we said in flat mirror, one of the properties that they have, the image that going to be produced is virtual image. But in here, no, it's different. The image property that you have is real image. You know why the real image? Because the image that's going to be created or produced, the image position, the image that are located in front of the spherical mirror, not behind the spherical mirror like the flat mirror. Because in flat mirror that we have said, we have explained the picture that become produced behind it. That's why we said virtual. But now in here different totally, the image become produced in front of the spherical mirror. That's why this is called real image. This is one of the property actually. And the second property that we have in flat mirror, it was the object size and the image size, both of them, they have same size, but here no different. Look, this is the that one is the object size that we have put it in front of this sphere, this concave spherical mirror. This is the object, but this is the image that created. Look, this size is greater than the object size. Their size totally different. They are not same. This is the size of the image and this is the size of the object. They are not same. They are not equal. So in spherical mirror, we understood now. It's a real image because the image that we have in front of the mirror and their size are not same, different. And one of the property that is really important, in flat mirror, we said the object and the image, both of them are upright, like both of them, they have same direction, but in here is different. This is the object size and the size is to the up, but that one is the image size, the size of this image is to the down. So their size or their direction different. This is to the up, this is to the down. So this is like a flipping, upside down. Good. We have a question now. Why we are using concave mirror? Because it can be used to form image. We know we are using any of the type of the mirror to form or to create image that are larger than the object or smaller. If you notice that in here, I told you this image larger than the object. That's why we are using a concave spherical mirror. This is the picture. Look, this is the picture of producing image in spherical. This is a spherical mirror. We see that, and as I told you in the previous section, that light or ray came out from any of the object. In here, for example, this light came out from this object and can hit or strike this surface. After that, going to be reflected right in that direction. Then another light in that direction came out from this object. It can reflect and it goes by the opposite direction like that. So we see that in this is the first light after reflection, and this is the second light after reflection. Both of the light, they are intersecting in this point. Both of the light, they are intersecting in this point. So that means in here that the image is going to be produced, because as I explained in the previous video, same thing like a flat mirror. We said if two line or two light or two ray, they are intersecting in one of the point, it means in that point image that we have. So this is the first line going to be reflected, and this is the second line going to be reflected. In that points, both of them, they are reflected. So it means in that point that image is going to be created or produced. Take a look. In here that you have image. If you notice that the property of this image, this is the object. This is the object. This is candle, I think, right? This is the candle. This candle direction is to the up, right? But that one is to the down direction. So they are not upright and they are upside down. Their direction is different. This is the first property. The second property, if you notice that the size of this image totally different than the size of the object. This object size is greater than the image size. The image size are smaller than the object size. So this is the second important property. The third important property, in here we say this is a real image that we have. Why real image? Because this is behind the mirror. There is no image behind the mirror. Actually, we have the image in here, in front of the mirror. Because we have an image in front of the mirror, it means this is called real image. But in flat mirror, we said the image we have behind the mirror. So because it's behind mirror, it was the name. It was a virtual image. But in here, it's called a real image. Let me write down the difference between of them. The difference between real and virtual image. First, real image and virtual image. Okay. The first property, we said the image that located in front of the mirror, in front of the mirror. For example, this is the concave spherical mirror, and this is the concave spherical mirror. There is image in here. This is the image point. So because you have image in front of this mirror, this is called a real image, because located in front of the mirror. Second property, can be displaced on physical surface. Can be displaced on a physical surface. On a physical surface. If you remember, in flat mirror we have said that can never be displaced on the physical surface because the image it was virtual. But in here, because since the image it is real image, it means can be displaced. Yani we can see the image that on the surface, not behind it. The third property, it is always inverted. It is always inverted. And the direction of the picture and the object and the image are opposite directions, are flipping, inverted. For example, this is the direction of this picture like that. This is the direction of the object. After that, for example, we have explained light came out from this source and going to be reflected in that direction. Another light, it came out from this source and like that direction, then it reflects back by the same direction. We see that in here they are intersecting both of the line. So in here we have image, but the direction of the image is like that. They are. Let me make it smaller, like that. This is the image that you have in here. This is the image position. This is the image. Look, this direction is this direction of triangle like that, but this direction is to like this shape. This is the triangle object, but this is the image. The direction is to the down, the shape. They are inverted, they are flipping, they are opposite directions. So even though, so this is called inverted, and direction is to the down, inverted. And the size of the object is greater than the size of the image. Another property slip. Actually, there's not property. This is definition of real image. An image formed when rays of light actually pass through the points of image. You know what is the meaning of definition? So easy. The question said an image formed when the image is going to be created. It's actually when the image become produced. It's actually this is the position of the image that's produced. An image formed when a rays of the light actually pass to the point of the image. For example, this is the object light came out from the source. It's going to be like that direction, then it's going to be reflected back in this direction. And this is the second light going to reflect back. We see that this is the first light and this is the second light. Both of them, they are intersecting in this point. Actually, the rays of the light actually pass to the point of the image. And these two rays of the light, both of them, they are passing through this point of the image. That's why in here that we have image, but not like the virtual. If you remember in virtual, I have explained and I told you the image actually, we think like the image, it passed behind the mirror. Actually, we don't have any picture behind the mirror. But I mean, we don't have any light. We don't have any light that it goes back behind them. There is no light because all of the light are reflected. But still we have image behind the mirror. We explain in flat mirror. But in here it is different. This is a real image, and real image, all of the line, they are passing and reflecting, and they are passing through this point. So in here we have image. So this is about real image. But in virtual, in here we have located in front of the mirror. But in virtual, same thing, but we say it located behind the mirror. Behind mirror. For example, like a flat mirror. And here it is written can be displaced on a physical surface. Same thing, but we say can never be displaced. Same thing, but can never be displaced on a physical surface. It is always inverted, but in virtual it is always upright. The direction of the image that we can get the image at every time with the direction of the object. They have same direction. An image, actually done. I have told the difference between of them. One thing that's left, the definition of virtual image: an image that form at a point, image that form at a point, which light ray appear to come but actually not come. Which light appear to come but actually not come. Appear to come but actually not come. This is about virtual image. Then there's a definition of real image. We said an image formed when ray of the light actually pass through the image. As I told you, for example, this is the concave spherical mirror, and we have and this is the object. Light came out from this object and going to be reflected back in that direction, and this is the second ray. It came out from this source. It goes back, reflect back by that direction. We see that in this point, both of them, they are intersecting. So in here we have image. In here, an image format. We have this is the position of the image. Light passed through the point image. Both of the light, they are passing or intersecting in this point. So in here we have image. Good. So in here, students, we have one of the important questions, which is called mirror equation. Really important, this rule, because to solve example, this is called mirror equation. Mirror equation: 1 over p plus 1 over q equal to 1 over f. P is the object distance, and q image distance, f focal length. Let me tell you in here what is the meaning of all of them. Look, take a look in here. This in here, if you take a look in here, this is the object. This is the object. The object position. The distance between the object to the mirror, the distance between both of them, object to the mirror, this is called P. This is called P. And the distance between image, this image, to the mirror, this is called Q. Okay? The distance between object to mirror, P. Distance between image that's going to be created in front of the mirror to the mirror, this is Q. Okay? And one thing that's left, we have R. R or F. What's the meaning of F F, it means focal length. F, it means focal length. So take a look, Baba. Let me erase this. The distance between this point to here, this is called focal length. Focal length. Good. Let me solve the example. So now we understood actually. Take a look back in here. You can understand here more. This F capital. This F capital. This F small is focal length. This is focal length, as I told you. Focal length. Focal length is the distance between this focal point to here. This is the distance between this focal. This called, if you have F capital, this is focal point. The distance between focal point to this back of the surface, this is called focal length. Okay, the distance between this focal point to the back of the surface is called focal length. But this is called focal point, but the distance between of them is focal length. We have another parameter which is called R, radius of the curvature. R is a distance from the mirror surface to the center of the curvature. R is the distance between R is the distance from the mirror surface to the center of the curvature. The distance from this mirror surface to the center of the curvature, this distance is called R, and this is focal point, and the distance between focal point to this surface is focal length. Okay, and this is distance between this surface to distance between this surface of the mirror to the center of this spherical mirror is called radius of curvature. And this C is the center of this picture. This is the center of the procedure, and the distance between this center to this surface called R, radius of the curvature. Okay. Let me solve example now, but before to solve example, we have some notes you should know. Actually, we have this note too. M, it means magnification, which is equal to h dash over h, or equal to negative q over p. M is the magnification of the image. For example, if the image is going to be large or small. Magnification equal to image height over object height, or image distance over object distance. H dash يعني image height, h يعني only object height, q image distance, p object distance. We have some not important. Take a look. If m, the magnification, if the result of the magnification is greater than 1, it means the image is larger than the object, يعني magnified. But if magnification less than 1, the image is smaller than the object. You should know this. But if the magnification is equal to 1, it means the object and image size they are same. This is about magnification. If magnification greater than 1, if the magnification greater than 1, the image greater than the object. But if the magnification less than 1, the image smaller than the object. But if the magnification which is equal to 1, it means that the object and the image, both of them, they are same size. If the type is real image, so we have some important students. If the type of the image real, immediately you should know directly Q positive, M negative, H dash negative. But if the type of the image virtual, M positive, H dash positive, Q negative. In here it's written all. So let you solve. We have this six configuration about concave spherical mirror. Now this six configuration about it, important actually. So be with me step by step. Image created by the concave mirror. We have six type of picture that we can make it in concave mirror. The first one, look, this is the shape of concave mirror. We know this. Where did this light it came? Where did this light it came? Where is the source actually? In here, the source that these lights they are came at infinity. And we don't know exactly the position of the source that the light came out from it. We don't know. So the object that they are emitting light, we don't know the position. So we say that the object at infinity. We don't have where is the place of the object. Where did light came out? We don't know. So the object at infinity. So the object at infinity, if you notice that all of the light came in the same direction, and all of them they are reflecting, and all of them they are focusing on this point. After reflection, all of them they are focusing in this point, on this focal. We say this focal point. All of them they are reflecting and going and focusing and intersecting and passing through this point. So it means because all of them they are passing through this point, it means that image going to be formed or image going to be produced on this focal point. If you notice that, we have image at what? At F. We have image at F capital. So this is a real image. Why real image? Because image that in here you can produce image in front of the mirror. In front of the mirror. Second type of the image. Now we know exactly the position of the object. Look, we have this pencil. Where is the position of the pencil? In here it is written outside C. Why outside C? Because the picture, the pencil's position is from the left side, so it means outside the C. That's why. If it's from the left side, and outside the C. So the object position is outside C. We see that light came out. The first light came out and it goes in that direction. Then it's going to be reflect back in this direction. And this is the second light. It came out from this source and going to reflect in that direction. And this is the last ray. It came out from this pencil source and reflected back by the same direction. We see that at which point that all of the lines they are intersecting, which is clear, huh? Look, all of them they are intersecting in this point. This is the first light like that, second light like that. All of them they are intersecting in this point. Because all of them they are intersecting in this point, it means in that point we have image. Look, this is the picture. This is the shape of the image that become produced in this point because all of them they are passing through this point. So this is the This is the location. The image are located in here, where between F and between C, between F and between C, the image position between C and between F. In here it is written real again. And why real? Because again the image we have in front of the mirror. This is real, of course. Inverted. Look, we have inverted. Why inverted? Because look at the direction of this image to the down, but that one to the up. They are flipping, right? So this is inverted. And at the same time, the size of this object is greater than the size of the image. Yeah, the image less than the object. So in here, magnification, it must be less than 1. Magnification, it must be less than 1 because magnification less than 1 because the image size less than the object size. Take a look in here. Take a look. This is the image size. And this is the object size. The image size less than the object size. So So guys, take a look in here. As I told, the magnification less than 1, because look, the image size is less than the object size. This magnification less than 1, and even the direction of this image will down, but this to the up, so they are inverted or flipping. Look, magnification less than and inverted. The second type, look, this is the first image actually. The first light came out from this source and it's going to reflect back in that direction, and this is the second light going to be reflected to the left side. If you notice that, and at which point that the light are, both of the light, they are intersecting in this point, look, of course, and this is the first light going to be, the first lights are passing to that direction, and the second lights to that direction, so both of them, they are intersecting in this point. So that's why in here we have image, because I told you, if two lights, they are intersecting at one point, in that point there's image. So again in here we have image, but let me read the property. Look, the property configuration. Where is the object position? The object position at C. This is the object that we have at C. The object at C. Real image, because we have image in front of the mirror. Again, the position of the image, same thing at C. Look, it's same thing again at C. The image, the object and image, both of them, they are located at C place. Inverted, again inverted. Look, the direction of this to the down, but that one to the up. Opposite, flipping. Magnification equal to 1. Oh, be careful, Mr. Why magnification equal to 1? Because both of the pencil, they have same size, same size, because magnification equal to 1. This one, this is the object. We are putting the object at where? At F. The object placed at F. And the object, they are radiated. The first light and going to be reflected back in that direction, and this is the second light in that direction. In here we see that both of the light, they are not intersecting in each other. They are not intersecting with each other. Both of them, they are reflecting back and they are going in this direction. Both of them, they are reflecting back and they are passing in that direction without intersecting. In that case, as I told you, one of the conditions to produce image, both of the light, they must to intersect each other. But in here, there is no intersection. In that case, we don't have any image. We don't have any image. Look, image at infinity, no image. Why no image? Because the two lines after reflecting, they don't intersect in each other. The last case, I think I haven't explained this. Okay, this one we have. I am going to put object between C and F. The object position between where? Between C and F. Good. They are emitting the first light in that direction and is going to be reflected to the left side. And this is the second light came out in that direction and going to be reflected back in that direction. And this is the last light came out in this direction. The last light, it emitted from this object to that direction. If you notice that all of the three line, all of the three line of three rays, they are intersecting in this point. Look, take a look in here. So it means in here we have image, and the image position is outside C. As I told you, if you have left side and outside, image, you can fix it. This is wrong. The image that you have outside C, here, because this is the image, and we have image from the left side and outside C. Again, inverted the direction, flipping again. Look, the image flipping, inverted, and the image size. Look, and the image size is greater than the object size. Look, the image is greater than the object size. It means magnification greater than 1. Magnification greater than 1, because image is greater than the object size. Greater than 1. Last type that we have in here, different students. Just take a look here. Important. I'm going to put this object so close to this surface. I'm gonna put this object, this pencil in here, so close to this surface. A lot of multiple lines came out from the source, and they are reflected in multiple directions like that. one of them reflecting back in this direction, the other reflecting back in that direction, and so on. Again, in here we see that in this case, actually, image that we have in this case, we have image behind the mirror. If you remember, as I told you, as I have explained it, extend this all of the line, we see that behind the mirror, in this point, they are intersected. So in here we have image. In this case, if we are putting this object so close to this surface, we see that the image that we have behind the mirror now. Because behind the mirror, the type of this image, virtual. Look. So here we will say object inside F. Why inside F? Because this is the F focal point, and we have object to the right side. In here, we can say object inside F. In here, virtual, not real. Mr. Why? Because in here we have image behind the mirror. If we have image like those kind of property in front of the mirror, for example, we have image in front of the mirror, this is called real image. But in here we have image behind the mirror, behind it, so this is called virtual. And in here is upright. Every time virtual image, they are producing upright image. Upright, all of them, they have same direction. Look, same direction. And magnification greater than 1, of course, because the image size is greater than the object size, magnification greater than 1. And we have image behind the mirror. I have to understand because it was so important. So now we are going to be solving example about image with concave mirror. Before to solve example, I have to remind you some notes. Okay, some notes, students. But first, let me read the question. A concave spherical mirror. In here we have which type of mirror? Concave. Has a focal length. F small focal length equal to 10. Locate the image pencil that is placed upright 30 centimeter from the mirror. Find the magnification of the image. In here, first you have to determine the size and magnitude of the focal and object size. In here, actually, we should know, because concave spherical mirror, in a concave spherical mirror has a focal length 10 and f small 10, and locate the image pencil. Locate the image of the pencil that is placed. We are putting this pencil is placed upright 30 centimeter from the mirror. And this is the object distance. Let me understand you by the picture. This is the concave spherical mirror and has a focal length. For example, this is the distance of the focal length, which is equal to 10 centimeter. Image, we have this pencil. This, for example, the pencil. This is the pencil. This pencil distance is upright and 30 centimeter from the mirror. We say the distance between the object to the mirror, it's P. So this is P, 30 centimeter. The distance between object to the mirror, which is called P. P is object distance. So the question said, find the magnification. Find the magnification. Good. So let me find the magnifications now. Magnification. To find the magnification, magnification, we said the rule of magnification, it was M, which is equal to negative Q over P. How to find the magnification? Actually, we have P. The P is equal to 30, but we don't have Q. You have to find the value of Q. Q, it is image distance. The rule, it was like that, 1 over P plus 1 over Q, 1 over Q, which is equal to 1 over F. We have to find the value of Q. We have the P, write down 1 over the value of P equal to 30 centimeter plus we want to find the value of Q equal to the focal length 10. To find the 1 over Q, take this fraction to the right side, write down 1 over Q equal to 1 over 10 and take this to the right side, will be negative 1 over 30. Then you can use calculator in here actually. You can use calculator. 1 over 10 minus 1 over 30, we can calculate it will be 0.066. 1 over Q will be 0.066. But be careful, this is the answer of 1 over Q. We have to get the value of Q. So flip this. Write down Q equal to, flip it will be 1 over 0.066. Divide this. 1 divided by 1, 0.0666. The answer, 15. So the value of Q, image distance, equal to 15 centimeter. So this is the value of Q. We find the value of Q, so immediately we can put the value of Q instead in here. Instead of the only substitute, write down the negative sign, and this is the 15, and the P it was 30. Divide both of the negative 15 divided by 30, it will be negative 0.5. Negative 0.5. Okay. So this is the answer of the first question actually. Good. Now, for the second question. So now students, we have solved this question. But let me tell you one thing, guys. Look, take a look. The value, the answer of Q, it was 15 centimeter, and the value is positive 15, right? Because it's positive, so we should know that. We have to know that because positive means that this is a real image, and the image inverted. Real image and inverted. Example, another example. Find the image distance and magnification of the mirror in the sample problem when the object distance. Object distance, يعني this is the first P and this is the second P. P1, P2. Are the image real or virtual? Are the image invert or upright? So first of all, actually, you have to solve it. Then we can decide is it real or virtual. The first P in here that we have, object distance, يعني P1 10. P1, which is equal to 10. P1 equal to 10 centimeter. P1 which equal to 10 centimeter. And the previous questions focal length, we have to use the previous sample actually. The focal length. Let me check what was the number of focal length. Focal length, it was 10 centimeter. So we have to, first of all, in here, to decide are the image real or virtual, you have to find the Q. Q is the image distance. Yalla. 1 over P plus 1 over Q equal to 1 over F. So we have P1 each equal to 10, and it will be 1 over 10. P1, Q1. 1 over 10 plus Q1, we want to find the value of Q1 actually. Focal length, which is equal to 10 again, 1 over 10. How we can find the value of Q? Take this fraction to the right side. 1 over Q1 equal to, bring down this 1 over 10 and take it to the right side, it will be negative 1 over 10. In here, take a look, students. 1 over 10 minus 1 over 10 will be 0. And 1 over Q1 will be 0. In that case, it means 0. In here, there is no image because the result is 0. No image. We don't have image in here. We don't have image because the result 0. For the second part, if the object distance b will be 5 centimeter. 5 centimeter. Again, we will use the same. We are using the same focal length, 10 centimeter. Go find the value of q, image distance. Okay, 1 over p2 plus 1 over q2, which is equal to focal length. P2, the value of the object distance, which is equal to 5, so it will be 1 over 5 plus, and Q, we have to find the value of Q, 1 over Q2 equal to the value of focal length, the same value, 1 over 10. So to find the value of 1 over Q2, take this fraction to the right side. 1 over Q2 equal to 1 over 10, and take this to the right side, will be negative 1 over 5. You can use calculator. 1 over 10, 1 over 10 minus 1 over 5. The answer, negative 0.1. 1 over Q2 equal to negative 0.1. So to get the value of Q2, as I told you, you have to flip this number. The result, Q2 equal to 1 over negative 0.1. So divided by 1 over negative 0.1. So the answer, negative 10. The image distance, negative 10. Negative 10 centimeter. Look, Baba. The question said, are the image real or virtual? Because in here we have negative sign, we have negative number, the value of Q is negative. Because it's negative, the image virtual. And is it inverted or upright? Because the value of Q is negative, so the image is upright. Upright. This is about question 1. Question 2. A concave shaving mirror has a focal length 33 centimeters. Let me write down the focal length 33 centimeters. Calculate the image position. Calculate the image position. Image position يعني find the Q. Image position, it means find Q. A bottle placed in front of the mirror. Of course, a bottle يعني the object. We are putting this bottle in front of the mirror. So the distance is 93. يعني this will be P. So in here you have to find the value of Q. Find the value of Q. And the distance of the bottle we are placing in front of the mirror, P, will be 93 centimeters. Calculate the magnification. The question said calculate the magnification. Is the image real or virtual? Or the image inverted or upright? Okay. First of all, we have to write the value of Q. We have to find the value of Q. 1 over P plus 1 over Q equal to 1 over F. Okay. And instead of P, we have the value of P, which is equal to 93 centimeters. So write down 93 centimeters plus 1 over Q. Since in here is unknown, we have to find the value of Q equal to 1 over F. And the value of F, focal length. And in here, we have the value of F focal length. Only substitute the value of focal length and put it in here. It will be 1 over 33. How we can find this fraction, how we can make these fractions alone, take the other fraction to the right side. So 1 over Q, which is equal to 1 over 33, and take it to the right side, will be negative 1 over 93. Okay, 1 over 33 minus 1 over 93. So the answer is 0.095. 1 over Q, 0.095. This is the answer of 1 over Q, but how we can get the value of Q? To get the value of Q, flip this number. It will be 1 over 0.0195 divided 1 over 0.095 195. The answer will be 51. The answer will be Q will be 51. Q will be 51. So the answer by positive, because in here the answer by positive 51, it means this is real and inverted, because Q is positive and real and inverted. Real and inverted. Okay. And even though the question said draw the diagram to show where the image form. Draw the diagram. So okay, let me draw the diagram for you in here. Look. For example, this is the mirror, and for example, this is the focal length, 33 centimeter, and this is the distance of the bottle or any object. For example, this is the bottle shape. The distance P to the mirror surface P, which is equal to 93 centimeter, and we have to find where did the image going to be created, the Q. We found the value of Q, which is equal to 51. 51. So 51. So the value of Q, which is equal to 51. The image maybe are here or in one of the place. Q equal to 51, because the distance between this object is 93 centimeter and this is 53. The position of the image may be in here. The position of the image, and real and inverted, because in front of the mirror. Inverted, yani the picture should be like that. Inverted. Okay. This is about question 2. Question 3. Question 3. A man stands a distance 25 centimeter in front of the concave mirror. A man stands. So this it means the object, a person or any person, stands in distance in front of the concave mirror. So this is the P, the object, and sees an upright image, distance 15 centimeter behind the mirror. Be careful. Behind the mirror, يعني the image is virtual. يعني if the image will be virtual, يعني the value of Q, it must be negative 50 centimeters. Students, be careful, because we have said and I have told you, if Q is negative, يعني the image that become produced behind the mirror, and this is virtual. Behind the mirror, virtual, add negative to this value will be negative 50. What is the radius of the curvature? We have to find the radius of the curvature, and what is the magnification? Good. Students, so sometimes the questions they will ask us to find the radius of curvature instead of the focal length. So the value of P equal to 25 centimeter and the value of Q, which is equal to negative 50 centimeter. What is the radius of the curvature? It was R capital, if you remember. We are applying the same rule now, 1 over P plus 1 over Q, but instead to write down 1 over F, since in here we don't have focal length, we have to write down 2 over R. And instead of 1 over F, we're going to write down 2 over R. 2 over R. Okay. To find radius of the curvature. So the value of P 25 plus the value of Q, negative 50 inside the bracket equal to 2 over R. Bring down 25, negative, the different sign still will be negative, 1 over 50 equal to 2 over R. So in here, minus both of them, 1 over 25 minus 1 over 50, 1 over 25 minus 1 over 50, and the answer 0.02. The answer 0.02 equal to 2 over r. So how can I get the value of r in here? Multiply both of them. 2 times 1 will be 2 equal to r times this number will be r 0.02. To find the value of r, divide both of them by 0.02 and 0.02. This will be cancelled, so 2 divided by 0.02, the answer will be 100. So the value of r 100 centimeter. And the question said at the same time find the magnification of the image. We can use this rule, m equal to negative q over p. So we have the value of q. Look, Baba, just be careful in here. This is the negative of the rule, but the q value still is negative. And here we have another negative. This negative of the rule. In here, the negative of the value of q. So put this negative 50 inside the bracket. This negative of the number, this is the negative of the rule. And the value of p, in here we have 25. So negative with negative will be positive, 50 over 25. So 50 divided by 25 will be 2. Magnification equal to. Because the answer is positive, because the question said is the image real or virtual, actually. Of course the image is virtual because in here you have negative sign. Virtual. And because virtual, the image is upright. And students, if you notice that in here the magnification, in here 1, we said if the magnification greater than 1, يعني the picture is magnified. Alright? In here, because since we have this number is we have 2, so this is greater than 1, so the picture is magnified. So this is that one. Sorry, this one upright and virtual. Why virtual? Because q is negative. Now we are solving the last example finally about this section. Last example. Good. Take a look. A pen. Place it. A pen is placed a pen. Okay. The question said, let me read by myself. The question said, a pen is placed 11 centimeter from a concave spherical mirror. A pen placed, yeah, this is the value of P, object at distance, 11 centimeter. Produce real image. And the question they told us that we have in here real image. Real image, it means the Q, it must be positive. Okay. Produce a real image at 13.2. The value of Q, 13.2 centimeter from the mirror. What is the focal length of the mirror? What is the focal length? Find focal length of the mirror. And what is the magnification of the mirror? Oh, sorry, what's the magnification of the image? This is the first part of the question because this question includes 2 parts. Let me solve. So guys, for information, this is the question 4. Okay, last question. How you can focal length? We are using the same rule, 1 over P plus 1 over Q equal to 1 over F. P is the distance 11, 1 over 11 plus Q 13.2 which is equal to 1 over F. So and here so we are going to find the value of focal length as the question said in here. Look, take a look. Let me read again for you. A pen placed 11 centimeter from a concave spherical mirror and produce a real image. Real image, and this is Q. What is the focal length? Find if, and what's the magnification? This is the first part. Look. First use this calculator and plus both of them. 1 over 11 plus 1 over 13.2 will be 0.1666 equal to 1 over f. How you can find the value of focal length? As I told you, flip this number. Will be 1 over 0.1666. 1 over 0.1666, and the answer will be, the focal length will be 6 centimeter. We found the focal length, but at the same time the question said find even though magnification equal to negative q over p. The value of q that we have in here 13.2 with the negative of the rule, and the value of p 11. So 13.2 divided by 11. 13.2 divided by 11. The answer 1.2. The answer 1.2, but with negative. Okay. So this is true real actually. Look, the magnification is negative 1.2. The magnification is negative 1.2. This is about the first part. So the second part of the question, the question said if the pen is placed at 27 centimeter. Now we are going to change the place of the pen. First it was 11 centimeter from the mirror, but now I'm going to make it far away from the mirror. To change the position, it will be 27 centimeter from the mirror. So now the value of P will be 27 centimeter. What is the new position of the image? What is the new position of the image? And find the image position. And again, find what Q. Easy, I think this lesson really. And what is the magnification? Again, what is the magnification of the new image? Is it virtual or real? What is the magnification? What is the magnification of the image? Okay. Yeah. We have to find the Q image position, image distance. 1 over P plus 1 over Q equal to 1 over F. We have F, we have P object at distance, which is equal to 27, plus you are going to find Q. But where is Mr. the focal length? In here, in the previous part, what number that you have, we use it? In the previous one, what number that it was focal length? We found the value. It was 6, I think. Yes. Yes. The value in the previous part we found the value of focal length. It was 6. So in here we can get the benefit from the first part. Look, we found the value of focal length. It was 6. So put the value of 6 for solving the second part. So 6 will be 1 over 6. 1 over Q. Take this fraction to the right side. Bring down this again. Take to the right side, it will be negative 1 over 27. Okay, 1 over 6 minus 1 over 27. So the answer is 0.129. 1 over Q will be 0.129. Then to find the value of Q, flip this number again. Flip it, will be 1 over 0.129. Flip it. The answer will be 7.75. So the image distance Q equal to 7.75. 7.75. The question said, is it real or virtual? Actually in here, because the value of Q is positive, right? Positive. It's not negative, it's positive. Because it's positive, so this is the type of the image, real image. and the image is upright. Real image. But the question, even though the question said find magnification, the magnification m equal to negative q over p. The value of the q that in here we have, because we found the value of q, which is equal to 7.75, negative 7.75, and the value of p in here that you have 27. And instead of p, write down 27. So 7.75 divided by 27, the answer will be negative 0.287. So the second part answer, Q 7.75, the image distance at the magnification negative 0.287, and the image is a real image. Students, actually today is enough because we explained the first part. For the next section, inshallah, we are going to be explaining the convex spherical mirror and to solve even the example. Thanks for watching, and hope you get benefit from all of them. Have a nice day.